Now, this next theorem is called the mean value theorem, and it is actually a direct result of Rolle's theorem. So this says that if f is continuous on the closed interval from a to b and differentiable on the open interval from a to b, then there exists a number c in the interval from a to b such that f prime of c is equal to f of b minus f of a divided by b minus a. Now, these two sides of this equation should look pretty familiar. This would be the slope of a secant line through the points A, F at A, and B, F of B. And this side right here is the slope of the tangent line to F through x equals C. So what's really going on here is you've got your points AF of A and BF of B, so this would be your secant line. And it's saying there's some point in this interval where if you find the tangent line, it's going to be parallel to that secant line. So you can see both of these lines would have the same slope even though they come from different places. So this is what the mean value theorem gives us. Now notice that the mean value theorem only requires f being continuous on a closed interval and differentiable on an open interval. It does not require f of a and f of b to be the same value. So there's one less condition on this than there was on Rolle's theorem. Now, in some instances, it can be useful to rewrite the concluding equation in the mean value theorem by just multiplying through by that b minus a. So you would get f of b equals f of a plus b minus a times f prime of c. And they also solved for f of b. So you'll see that in some applications. Now, the mean value theorem is considered to be one of the most important theorems in calculus because it can be used to prove so many other theorems. So this is kind of a big one, so pay attention to this, especially if you're planning on going on to a real analysis class in the future. You'll see this again. Now, one thing I do want to point out, when they say the mean value theorem, they are talking about like mean in terms of an average. It's not that it's a very angry theorem or anything like that. So don't have any hostilities with the mean value theorem. It's just an average kind of thing. So let's look at an example. I want to consider f of x equals x squared minus x minus 12. And I want to find the equation of the secant line joining the points -2, -6, and 4, 0. So we can see those points about here and here. So we know that we're going to be looking for the equation of roughly this line. Okay, so to find the equation of a line, I need the slope, so that would be 0 minus -6 divided by 4 minus -2, which would be 6 over 6, or 1. And I'm going to use my point slope formula. So I'm going to pick the 4, 0. So I'll have y minus 0 equals equals 1 times x minus 4. So y is equal to x minus 4. So that would be my equation of that line right there. The second part says to use the mean value theorem to determine a point C in -2 to 4 such that the tangent line to C is parallel to the secant line found in part A. Now, what we're doing here, remember the mean value theorem needs the following. We need, number one, that f is continuous on the interval from -2 to 4 with brackets. And 2, we need that f is differentiable on the open interval from -2 to 4. And we do get both of these because f is a polynomial. So we're good here. The mean value theorem does apply. So at this point, we just need to find the c. So we know that there is a c in the interval from -2 to 4 such that f prime of c equals f of 4 minus f of -2 over 4 minus -2. And we've already found that that's equal to 1. So f prime of x for this problem, remember f of x was x squared minus x minus 12. So f prime of x is 2x minus 1. So that means that f prime of c for any c would be 2c minus 1. So I'm going to set the 2c minus 1 equal to this 1 right here. So if I add 1, I would have 2c equals 2, and if I divide by 2, I would have c equals 1. So this is the c that I'm looking for. So the next part says find the equation of the tangent line through that c. So we need to know the point. We already know the slope is going to be 1, but we need to know the point. So x is going to be c or 1, and y is going to be f of 1, which is 1 squared minus 1 minus 12, or negative 12. So I'm going to find the equation y minus negative 12 equals my m, which is 1, times x minus the x, which is 1. So y plus 12 equals x minus 1, and if I subtract 12, I get y equals x minus 13. So that is my line. And then I'm going to graph both of those lines together. So the secant line and the tangent line. Remember, the tangent line, or the secant line, was here from negative 2, negative 6 to 4, 0. So that's my secant line. My tangent line is going to go through negative 13, so roughly about here, and it's going to be at x equals 1. So it is here, and you can see that that line, if you draw it correctly, is parallel to the line that we drew above. Now, this is another interesting example involving the mean value theorem. This says that two stationary patrol cars are equipped with radar are 5 miles apart on a highway. As a truck passes the first patrol car, its speed is clocked at 55 miles per hour. 4 minutes later, when the truck passes the second patrol car, its speed is clocked at 50 miles per hour. We want to prove that the truck must have exceeded the speed limit of 55 miles per hour at some time during those 4 minutes. So we're going to start by letting t equal 0 hours. And in any case, that's going to be the time that the truck is going to pass the first car. Okay? Now, when t is equal to 4 over 60, because that's 4 minutes, or 1/15 of an hour, this is going to be the time the truck passes the second car. So basically, I've got two cars, and I know that they have a distance of 5 miles between them. And I've got a truck that's passing them. So this is going to happen at t equals 0. And we know that at t equals 0, the truck was clocked at 55 miles per hour. And we know that at t equals 1 over 15, the truck was clocked at 50 miles per hour. Now, from the looks of it, it looks like the truck didn't pass the speed limit. It looks like they were going the speed limit and then they slowed down. But we're going to, so they probably wouldn't have gotten caught by the police cars, but we're going to show that, that they did have to at some point. So we're going to let s of t be equal to the distance traveled at time t. Okay? So at this point, and this is going to be the distance from the first car. So we're going to call s of 0, 0, and we're going to call s of 1 over 15, 5, because he's traveled 5 miles since the first car. So assuming continuity and differentiability, the average velocity would be equal to s of 1 over 15 minus s of 0 divided by 1 over 15 minus 0, which would be 5 minus 0 divided by 1 over 15, which would be 5 over 1 over 15, or 75 miles per hour. Okay, so what does the mean value theorem tell us? The mean value theorem says there must be a value of t in the interval from 0 to 1 over 15 such that s prime of t, which remember would be the velocity of t, is equal to 75 miles per hour. Now, 75 miles per hour is definitely above the speed limit of 55 miles per hour. So at some point in that time, that truck had to be traveling 75 miles per hour according to the mean value theorem. So this is definitely a case where the truck exceeded the speed limit.